Earth weighs approximately 60 sextillion tons, yet it appears to float effortlessly in space like a graceful blue balloon without falling downward. What force is holding it up? Isaac Newton was the first to offer an explanation. He proposed that weight doesn't necessarily imply a downward fall. Weight is simply the force exerted on an object by gravity. But space is a near vacuum, and the concept of up or down doesn't apply. Earth isn't floating on any surface. Rather, it is moving in a stable orbit around the Sun, locked in a dynamic equilibrium. In fact, one could say Earth is constantly falling toward the Sunday. However, it never crashes into it because of centrifugal force. Earth travels at a speed of 29.78 kilometers per second in an almost circular orbit. This motion produces centrifugal force that perfectly balances the Sun's gravitational pull. As long as this orbital velocity remains constant, Earth continues circling the Sun like a satellite. According to Newton's first law of motion, an object in motion remains in motion unless acted upon by an external force. With no friction in space and no opposing resistance, the angular momentum Earth gained at its formation 4.6 billion years ago is sufficient to keep it orbiting the Sun indefinitely. Even if the Sun's gravity were to suddenly disappear, Earth would simply continue flying tangentially into space. But Earth doesn't just orbit the Sun, it also travels with the Sun around the center of the Milky Way galaxy. This galactic orbit occurs at a speed of about 220 kilometers per second and takes roughly 250 million years to complete. The gravitational pull from the supermassive black hole at the galaxy's core, which has a mass equivalent to 4.4 million suns, is immense. Yet again, the Sun's orbital motion generates centrifugal force that balances this gravitational influence. Although interstellar gases and dark matter create some minor drag, they have little to no effect on Earth's trajectory, at least for the next several billion years. The solar system, and Earth within it, will remain stable during this time. Here on Earth's surface, gravity pulls objects downward. In orbit,